Hello, students. Coming to the second part of the module 2 with respect to the data. In the previous lecture, video 1, I have explained regarding discrete and continuous attributes. Now, moving to the next slide, asymmetric attributes. What is an asymmetric attribute? Only presence, a non zero attribute value is regarded as an important. Okay, so only presence of an attribute is regarded as an important. Means a value of an attribute should not be zero. So word present in a documents. So words present in a document, they are not symmetric because the words may appear in any sequence. Items present in a customer transactions. So different customers may buy different set of products. So the transactions may not be symmetric. My transactions may not be same as your transactions because my choices are different and your choices or your set of purchases will be different. If you met a friend in the grocery store, would you ever say that the following? For example, I see our purchases are very similar to the, since we didn't buy most of these same things. So we need two asymmetric binary attributes to represent one ordinary binary attributes. Association analysis uses asymmetric attributes. So association analysis, which we are going to cover in module number 3. So here there most of the attributes whatever we are going to use, they're all asymmetric attributes. So asymmetric attributes typically arise from the objects that are sets. So in association analysis, as we are going to analyze the market bucket transactions, so where objects will be present in terms of a set. So there we are applying asymmetric attributes typically. We are applying in the market bucket transactions, basket transactions. Okay, so now coming to the critics, incomplete. Incompletes, that is asymmetric binary, cyclical, multivariate, partially ordered, partially membership, relationship between the data. They are all incomplete data. Real data is approximate and noisy. So the data that we capture from a real time operation or a real time temperature recording, it will be having a noise. This can complicate recognition of the proper attribute type because I know when you are we are recording an online transaction or an online weather recording, at that time there will be a presence of noise. So for this reason, this can complicate recognition of a proper attribute type. Treating one attribute type as another may be approximately correct in those cases because of the presence of the noise. So, not a good guide for statistical analysis, may unnecessary strict operations and results. Statistical analysis often approximate. Just for example, using interval analysis for ordinal values may be justified. So, transformations are common but don't preserve scales. Can transform data to a new scale with better statistical properties? A little bit difficult part. So, many statistical analysis depend only on the distribution. So, more complicated examples, ID numbers. So these ID numbers, whether they belong to the category of a nominal, ordinal, or it is an interval, so that you need to decide. So number of cylinders in an automobile, whether it is again a nominal, ordinal, or a ratio. Next is bias scale, interval or ratio. So types of operations you choose should be meaningful for the type of data you have. So key messages for attribute types. So the type of operations you choose should be meaningful for the type of data you have. For example, we have different types of operations available. Either we have Operation such as distinctness, order, meaningful intervals, and meaningful ratios are only the four properties of the data. So, as we know, there are four properties of the data. Okay, so distinctness is one property of the data, order is another property of the data, meaningful interval is another property of the data, and meaningful ratio is also another property of the data. The data you can see, often numbers or strings, may not capture all the properties or may suggest properties that are not present. So, the numbers or the strings may not capture all the properties of a data or may suggest properties that are not present. Analysis may depend upon these other properties of the data. Many statistical analyses depend only on the distribution. Many times, what is meaningful is measured by statistical significance, but in the end, what is meaningful is measured by the domain. So, now, as already covered in the previous slides, the types of data sets. So, a record will have a data matrix, document data, and transaction data. Graph is a World Wide Web, molecular structure, ordered, spatial data, temporal data, sequential data, and genetic sequence data. Okay, so important characteristics of a data. So, first characteristics of a data is a dimensionality. So, the number of attributes. High dimensional data brings a number of challenges. Dimensionality, that is number of attributes. So, if you take the human body, what will be the different attributes? Height is one attribute, eye colors is another attribute, fingerprints are the another attribute, then skin color is another attribute. So, such high dimensional data brings a number of challenges. So, next is sparsity, only presence counts, whether it is present or no. That is a character. Next is resolution. Pattern depend on the scale. Resolution is another characteristics of a data. So if you capture of an image, what is dates on the resolution of the image, you are able to define a picture, either it is a clear or unclear, or able to view the content of an image very clearly based on the resolution. Next is the size. Type of analysis may depend on the size of the data. So if the size of the data is very large, then the analysis may take a large amount of time. Now, coming to the first example, record data. Data that consists of a collection of records, each of which consists of a fixed set of attributes. What is the record data? Data that consists of a collection of records, each of which consists of a fixed set of attributes. So, here, for example, transaction ID is one attribute, refund is another attribute, marital status is another attribute, taxable income is another attribute, whether a person taking a loan he is paying back or no, or a person who is being salaried is paying the tax or no, is another attribute. This is a set of record data, and this type of data is used uh, in data mining to determine which type of people are paying an income tax and which type of people are not paying an income tax. Next, coming to the data matrix, if data objects have the same fixed set of numeric attributes, then data objects can be thought of as an points in multi-dimensional space, where each dimension represents a distinct attributes. So, so what is being told? If data objects have same fixed set of numeric attributes, then the data objects can be thought of as point in multi-dimensional space. Means the data objects can be have values in different dimensions, where each dimension represents a distinct attribute. Such a data set can be represented by a M by N matrix. So, if you have a multidimensional data in a space, then the data can be represented in form of a matrix, where M is the row one for each object, and n is a column and each for an attribute. So m represents an object and n represents an attribute. So here attributes are projection of x load, projection of y load, distance, load, thickness is a projection of. These all things are the attributes. And the values 10.23 and 12.65 is a projection of x load, 5.27, 6.2 is a projection of y load, distance, load, thickness. So all these five attribute values can be represented in the form of an matrix of size m cross n. Now, document type of data. So each document becomes a term vector. Each term is a component attribute of a vector. The value of each component is the number of times the corresponding term occur in the document. So in each document, we have attributes defined. The value of each component is nothing but the number of times the corresponding term occurs in the document. So we have three documents over here, document 1, document 2 and document 3. So then what are the attributes here? Team, coach, play, ball, score, game, win, loss, timeout, season. So document 1, there are three teams. Coach is not present. There are being played 5 matches. The score is 2. 6 games have been done. Win 0. They have lost 2. And it's the season 2. Okay, so like this, a documented is an example of a document data. So now transaction data, a special type of data where each transaction involves a set of items. So consider, for example, if I go to a supermarket. So when I go to a supermarket, I have in mind I'm going to buy so many things. So let us take 5 customers. So each transaction involves a set of items. So consider, for example, 5 customers have visited a grocery store. The set of products purchased by a customer during one shopping trip constitute a transaction. So whenever a customer visits a particular store and during his first one visit, whatever he buy is a transaction. While the individual products that were purchased are called as the items. Consider, for example, the first customer with the transaction ID 1. So has brought bread, coke, and milk. So for customer 1, the transaction data record is he has buys 3 items bread, coke, and milk. Second is beer and bread. Whereas third customer has bought beer, coke, diaper, and milk. Whereas fourth customer has bought beer, bread, diaper, and milk. Whereas fifth customer has bought coke, diaper, and milk. This is an example of a transaction data. Next, coming to the graphical data. Example is a generic graph, a molecule, or a web page. So now a generic graph. Okay, so here, for example, so you can see, so generic graph 1 to 2 to 1, in between 1 and 5 bidirectional transaction, 2, 1, 2 and 5 are the 5 ways in which a data is being transferred. Useful links for the web pages, useful links. If you click onto the bibliography, you will get when you click bibliography link, it will open knowledge discovery and data mining bibliography. Then there again there are 2 links, books and general data mining. So if you click onto the books, so here reference books that are used are Osama Fayyad, grocery. These are the 2 reference, one by the Osama Fayyad and J. Roscollin. So if you go to the general data mining technique, so again it will open another 2 links. So another example of a graph data where benzene molecule is represented. Chemical formula for benzene is C6H6, which is represented as in the form of an hexagonal. This is a graph data. Now, coming to the ordered data. So, what is in data? What is the difference between a data and an ordered data? Okay, so ordered data wherein everything is ordered. So items, so sequence of transactions is called as an ordered data. So you have A, B, and C are the items. B, D, D are the events. So this is an element of sequence. So when I buy A and B, I may buy D or I may buy C and E. So when I buy B and D, I may buy C, sorry, C and E, or C and D, B, A and E. This is an ordered data. So next coming to the genomic sequence data. So what is a genomic sequence data? So the whole genome sequence is nothing but the process of determining the complete DNA sequence of an organism's genome at a single time. Okay, so this data represents the sequence of all organisms' chromosomal DNA as well as DNA contained in the mitochondria. So here GGTTCCGCT that represents the genomic sequence of the data where data is represented, the DNA structure of a particular human being is represented. Next is ordered data, spatio-temporal data. So here you can see the average monthly temperature of a land and ocean is recorded. You can see there is a variation in the temperature during every month. So at the top of the graph, you can see March different values, May different values, June different values, July different values, August. So for every month, the temperature variations are different. So not only during a month, there will be a temperature variation during a week also, maybe during a day also from morning to the evening. So next coming to the data quality. Poor data quality negatively affects many data processing efforts. So whenever you are trying to process a data, if the quality of the data is very poor, it will affect. The most important point is that poor data quality is an unfolding disaster. So if the data, whatever you are taking it for analysis, if the quality of the data is very poor, then that is an unfolding disaster. So poor data quality costs the typical company at least 10% of the revenue. The data quality is very poor, then 10% of the revenue is wasted and 20% is probably a better estimate, according to the Thomas C. Redman and DM review in August 2004. So, data mining example, a classification model for detecting people who are loan risks is built using a poor data. So, now if we take uh, employees of an organization and we classify them, if I give a loan to these people, whether they will repay or back or no. If the data, whatever if I collected that is wrong, and if I give a loan to a person who is unable to pay it, then credit worthy of candidate is denied. So some credit worthy candidates are denied. Means some of the people who were able to repay loans, you are not given the loans, and you have given the loans to the people who are not able to pay. That is nothing but more loans are given to the individuals that default. Means if you are giving a loan to a person who is not able to repay back, that is a poor quality of the data if you take into consideration. So now we have some questions here. What kind of data quality problems? How can we detect problems with the data? What we can do about these problems? So when we say a poor quality of the data, so what is the reason? What is the reason? because of which the data is getting poorer in quality. So if there is a poor quality of the data, how we can detect that problem? Then what we can do about these problems? So examples of the data quality problems is noise and the outliers, missing values, duplicate data, wrong data, fake data. All these are the examples of poor data qualities. Because of noise and outliers, the data may be poor. Because of the missing values, the data may be poor. Because of the duplicate data, data may be poor. Because of the wrong data may be poor. Because of the fake data may be poor. Consider, for example, for objects, noise is an extraneous object. So now, whenever you are recording a voice, or you are recording the temperature, or you are recording an humidity, so during that time, if an noise, you are recording a song, so during that recording of the sound, if a noise is added, that is a noise, an extra, so for an object, then that noise will get add to the original signal, and the original signal will lose its original value, and this noise will get added, because of which the data will be the poor quality, wherein the original data is lost and noise will be present. For attributes, noise refers to the modification of original value. So whenever a noise get added to a signal, so signal will lose its original value, and that is occupied by the noise. So example, distortion of a person's voice when talking on a poor phone, and snow on a television screen. So during rainy season, we will not get a proper quality of the channel. Or if you are talking on a phone where signal strength is very low, then there will be a distortion. So you can see on the left hand side two sine waves which are clearly shown, one by the green, another by the uh, blue. So on the left hand side, you have another graph where you have both uh, noise plus two sine waves which are being combined. Okay, next, outliers. Outliers, for example, what is an outlier? So, if a value of a particular data lies outside the boundaries that are defined, then that we call as an outlier. Outliers are data objects with characteristics that are considerably different than most of the other data objects in the data set. So, case one, outliers are noises that interfere with the data analysis. So, you can see uh, three red colored circles, they are called as an outliers. Outliers are noises that interfere with the data analysis, that will interfere. So a dense black dots will representing a complete data. So these three red colored data they are disturbing. Outliers are the goals of our analysis. So for example, credit card fraud detection. So if uh, a person is trying to access another person's credit card, so then at that time we are able to detect the transaction, because he may enter the wrong password or he may enter some wrong credentials. Or another example is intrusion detection. So during intrusion detection, what we do? So whenever a third person is trying to read your emails, or a third person is trying to listen to the telephonic conversations. Next is missing values. Reasons for missing values. Why there will be missing values into the data? Information is not collected properly. For example, people decline to give their age and weight. So if you are analyzing the people data, so some of the people will decline to give their age and weight information. So because of which, some of the values will be missing. Attributes may not be applicable to all the cases. So all the attributes. So for elders, annual income is applicable, whereas an attribute of annual income for the children is not applicable. Because of that, for a children, annual income is a missing value, and for elders, age and weight is a missing value. So now, how I'm going to handle these missing values? So if a particular data is having missing values, eliminate that data object or variable. Estimate missing values. Example, time series of a temperature. Example, census results. Ignore the missing value during analysis. So whenever you are analyzing the data, so ignore the values which are having some missing values. So there are four different types of missing values. One is MCAR, MAR, MNAR. So MCAR is missing completely at random. Missingness of a value is independent of the attribute. Fill in values based on the attribute. So if a particular object, if a particular attribute is missing, so based on the previous values, fill in the value of an attribute. Analysis may be unbiased overall. So next is missing at random. Missingness is related to the other variable. So because of one variable, another value of the another variable will be missing. So if I want to fill that, fill in values based on the other values. So almost always produce a bias in the analysis. Next is missing not at random. So missingness is related to the unobserved measurements, informative or non-ignorable missingness. So not possible to know the situation from the data. So next is duplicate data. So what is in duplicate data? So if the same data is present for a single person, or a single person is having two datas, then we call it the duplicate data. So duplicate data may include data objects that are duplicates or almost duplicates of another. Major issues when merging data from heterogeneous sources. So when you collect data from heterogeneous sources, these all heterogeneous sources, if they are giving a data belonging to a particular same person, then it will be a big problem. Example, same person with multiple email addresses. So data cleaning, process of dealing with duplicate data issues. So data cleaning has to be applied as we discussed in module 1, how data cleaning is done. So using data cleaning, what we can do, we can process it. So when should duplicate data not be removed? So we need to think on when duplicate data are to be removed and when they are not to be removed. Coming to the last point in the module 2, measures of similarity and dissimilarity. What is a similarity measure? Numerical measures of how alike two data objects are. It is similarity measure. So if you want to measure the similarity between the two data objects, okay, so if the two objects are alike, then the similarity is said to be high. Is higher when objects are more alike. If the two objects are same, then the two objects are similar. Often falls in the range in between 0 to 1. So if it is 0, they are both are distinct. So if it is 1, both are same. Now, if I want to measure dissimilarity measure numerical values of how different two objects are. So lower when two objects are more alike. So if the two objects are completely different, then there is completely dissimilarity. So minimum dissimilarity is often 0. Upper limit will vary. Proximity refers to the similarity or dissimilarity. Similarity or dissimilarity for simple attributes. The following table shows the similarity and dissimilarity between two objects x and y with respect to a single simple attribute. Attribute type is a nominal, ordinal, or interval or ratio. So now you take three attribute types. Here we are taking all the four attribute types: nominal, ordinal, and interval or ratio in the same. So nominal, d is equal to 0 if x is equal to y, and d is equal to 1 if x is not equal to y. This is dissimilarity measure. So similarity measure is opposite of that. That similarity measure s is equal to 1 if both x and y are same, and if it is 0, and it will be 0 if both x and y are not same. Ordinal, d is equal to dissimilarity x minus y by n minus 1. Values mapped to the integers 0 to n minus 1. If you are taking the values in bit from 0 to n minus 1, where n is the number of values, so then how are you going to measure the dissimilarity? X minus y by n minus 1, whereas similarity is just 1 minus d. Interval or ratio, in terms of interval and ratio, how we are going to measure the dissimilarity and similarity. Dissimilarity is d is equal to x minus y, where similarity is just s is equal to minus d, or s is equal to 1 by 1 plus d, or s is equal to e raised to minus d, or s is equal to 1 minus d minus minimum of d, or maximum of d minus minimum of d. So that is regarding the module 2. Here ends the module 2. So I thank for the PPTs given by Tan Sheinberg and Vipin Kumar, and the reference book I have used, the book I have used, Introduction to Data Mining, second edition. Thank you. Thank you, one and all.